Okay. So, Adrian, I would like to actually start a little bit with you here before we go
Okay.
into programming.
Okay,
Definitely,
sure.
we will start also today in Java. So,
Mm.
but I would like to know from you, do you know a way that we are able to calculate from 1 to 200? So it means that we add numbers from 1 until 200 like this
Mm, mm.
in less than 30 seconds. Do you know a way to do that?
Oh, I forgot now. Okay.
Have you taken something like that before?
The I mean not in my com science, but in maths, obviously we've done something like that, but not with coding.
Okay, so definitely this is not coding. This
Yeah.
is just a way. It is just a way that to tell you that to be able to find smart solutions. So we need to think first. So the hard way is that you say you take a calculator, or even you write on a paper 1 plus 2 plus 3 and so on until you reach 200. So, but you will never
Mm.
be able to achieve this 30 seconds challenge.
Yeah, yeah.
Okay, so let me see here. If we look at, so I will check with you if actually you still can remember, because there is a
Mm.
point actually from even solving this. Um,
Mm,
if
mm.
you know the secret, especially in automation, if you would do something for robotics, you
Mm.
need to understand that every system have a formula, a simple mathematical formula. If you manage to reach
Mm-hmm.
it, then this is quite excellent.
Okay.
It's not so complicated, but normally, especially with automation and robotics, typically it's a repetitive movement. Okay,
Mm,
and
mm.
the movement. So for every system, okay, they do a specific fixed task that always, most of the time it need only a small changes in the formula. So let
Mm.
me go on with you and see.
Okay. Okay.
So okay, let me, or maybe it's possible that I have it here so that we don't have to write it from the start. Yeah, we have something. Yes, I think. Yeah, let me see here. Okay, let me. This is more a bit simpler here. So,
Mm.
okay, let me see the color. Okay, good. We are able to meet this brand color. Okay, so now we set from 1 until 200. Am I right?
Yeah.
We divide that into two groups of numbers. From
Mm-hmm.
1 to 100 is a one group, and from 101 until 200, this is a second group. So we
Right.
say we divide them into two tables, table 1 and
Mm.
table 2,
Mm.
and it means that in total they are still 200. Okay, so
Yeah.
if you add 1 from table 1 plus this 200 from table 2, the result
Mm.
here is 201. And if
Yeah.
we add 2 plus 199, this is
Mm.
equal what?
201.
Okay, good.
Yeah.
And if we do here,
So, yeah, 201. Yeah.
so it means that you manage to find a way that instead of
Mm.
adding uh, the hard way, 1 plus 2 plus 3 and so on.
Yeah. Yeah.
So if you think about it, if you multiply, so the count here in each table is 100.
Yeah.
And the result of adding a number from each table is 201. So if you
Yeah.
multiply 100 by 201, so you can
Yeah.
reach actually what you want to achieve, which is
Mm.
the
Mm.
addition of the numbers, right?
Yeah. Yeah.
Okay, good. So now the second trick that I would like to ask you here. So let me
Mm.
try to, so that we think about it together. Now, if we have, if I want to tell you, now I want you to tell me how to add from 1 to 400. Can we do the same?
Should be able to, yeah.
Okay, so what could be changed? So here we created two tables, and each table
Yeah.
have 100.
Yeah.
Here we will
Maybe
also create the
200.
two. Yes, so
Yeah.
so from 1 until 200, and from
Yeah.
201 until 400.
400.
Okay,
Yeah.
but now the difference here, each table have 100, but here no, we will have
Yeah.
200 for each table. So,
Yeah.
and also we go the same, 1 plus 400 equal 401, and if we say
Yeah.
200 plus 201 equal also 401, am I right?
Yeah.
So if we multiply 200 by 401, it will come up
Yeah.
with a number, am I
Yeah.
right? Okay,
Yeah.
but now the key here is not to challenge you and tell you how to calculate. No, we
Mm.
want to reach the formula. So typically when, so now I would like you to see here, look at this
Mm.
and this.
Yeah.
So here we wanted to say add 1 from 1 to 400, here from 1 until 200.
Yeah.
So it means that if I want to calculate from 1 to 400, I divide the 400 by 2, then I reach
Yeah.
the count. This is the count, right?
Yeah. Yeah.
And then what is
You
this? What is
multiply
the
with
relation?
400 plus 1.
No, wait. We are
Okay.
not, wait. This
Mm-hmm.
400, what is this relation to 401?
This is the uh hmm.
It's okay. It's take your time to think. Okay, I make it easier for you. What is the
Hmm.
relation between 200 and 201? We are here to think about relations.
Hmm. Mm.
Okay, let me also discuss here.
Hmm.
What is the relation between 200? This is the number that we want to add to,
Yeah.
and this
Yeah.
100. What is the relation between them? Are we?
This is
Are you? Yes.
yeah.
Tell
Yeah.
me.
This is the count of the
Yes, I
so when you
understand.
divide it, yeah,
Yeah, but I divided this 200 by what to reach 100?
by 2. By 2.
Excellent. And here we
Yeah.
divided 400 by what?
2.
Excellent, excellent. So here
Yeah.
we divided by 2 to reach 200. So if I
Yeah.
want to say what is the relation between 400,
Right.
what is that?
Plus 1.
Excellent, excellent. So here also plus 1, right?
Plus 1. Yeah.
Excellent. So it means if I have, I want to add from 1 until 800, I don't want to make
Mm-hmm.
these tables anymore.
Yeah. Yeah.
I want to think in this formula. So I would say
Yeah.
to reach the result, we have
Yeah.
y. First,
Yeah.
x equal 800, which is the
800.
number that I
Yeah.
want to reach. So I
Mm-hmm.
divide x by 2
Yeah.
here,
Then
plus
times I
times.
thought times,
Okay,
no?
no, it's
Times
two.
x plus
Huh?
1, right?
Excellent. So this is actually what we want to reach.
Yeah.
So if you know this formula, you don't need to look at this kind of tables anymore. This is only
Yeah.
for initial analysis. The same,
Yeah.
you will also see with automation system that you can reach simple formulas like that. And normally it is not more complicated than that. It was as simple as that. Okay. So there
Mm-hmm.
is certain movement that you always want to take, and this movement is calculatable. So it means that you are able to predict it and calculate it and make a formula for it. If the customer want to change the amount of movement for the robot, you will find that they also have to go with the same formula, because everything around the robot is typically fixed most of the time. I mean 80% of the time. Okay. So
Yeah.
did I manage to get your attention here?
Yeah. Yeah.
Okay, perfect.
Okay.
So, and we will look together how we can use this kind of formula to put it in a code, in a Java code, to
Yeah.
make the customer is able to actually calculate any number, okay, that he wants.
Yeah.
So if he enter x equal 1000, if he use that formula, I mean, we put that formula in the code, and then it will immediately faster get the result for him. Okay.
Yeah. Yeah.
Okay, good. Okay, so we managed to get that one. So a little bit by little bit, we will actually think and take something called computational thinking. Have you taken that before? Computational thinking.
No.
So basically, computational thinking is actually taught to the people who studying computer science. So the key here is not to teach you only programming, but to teach you how to think, how to analyze a small problem, same like we have done now. We analyze the problem, we come up with a formula, we come up with a way that we always can make it easy for us to solve any problem. So this computational thinking actually need you to learn a few skills and need to learn and try to acquire those skills. So those skills that we will try to go through not only today, but always we will remind ourselves something called algorithmic thinking, which is developing an algorithm to solve a problem. Okay, this problem can be a coding problem that you need to do in computer science or Java, but also it can be another problem. Like I told you yesterday, algorithmic thinking, if they are going to make a manual in IKEA just to fix a table or a chair, so they need to also think in algorithmic thinking way. They need to solve a problem, and the algorithms that they want to describe to you in the drawing of the manual, this is actually something that if anybody repeat the same steps, he will reach the same final solution or destination. So if you add egg to flour to milk, in the way that it is described, you will end up with having a pancakes. Okay, so it means that if anybody follows it, then he will reach the same destination. No, and then we talk about something else called abstraction, which is hiding unnecessary details to reduce the complexity. And this is also we will learn a little bit about it. Um, Forget about automation at the moment, but do you know what's the meaning automation?
Yeah, like it's done by itself. You don't need to manually.
Okay, so they refer to the automation is a branch that you learn about typically if you're studying something related to robotics. So automation is automating any manual process using machinery. So a machine can be a small machine in the kitchen and or can be a long production line in a factory. So you want to automate instead of making shoes using hand, you want to make that in a factory that a production line can really produce it without a single human interaction. So the process of making cars and assembling cars, this is also part of the automation process in the factories. Okay? Okay, excellent. So we have something here called decomposition. So if you want to solve a problem, you have to really break it into small parts. So let me tell you that this concept you actually can learn to use it in your house or even in your normal life. So not only in solving problems of programming, but also so let me now give you an example. If I ask you, I tell you, Ashvin, that the house is quite dirty. Can you please try to clean the house up? Then Ashvin said, "Oh, that's too big. Huh? This 3 or 4 rooms have, and I'm alone. How can I do that?" So, but then if I tell you, Ashvin, what about if I tell you, okay, clean your own room only? So it will be slightly easier, right? But now also you start to think. So now the bed is messy, and then there is also books on the table. So I begin with which one? So, but then if I tell you, okay, now first forget about everything that I told you and focus on cleaning your table or your studying table or your desk. So I put a small single problem to you for you to solve. I think it is easier for your mind to actually solve. So
Yeah.
also the same when we're having a big projects that we want to achieve or to reach, either in coding or robotics or anything, we would like to cut the small problem, the big problem, into a smaller, manageable size problems that we are able to handle. And instead of cleaning the whole house one shot and taking care of a lot of things, no, we want to only focus on a small thing. So dividing a big problem into small problems, that's part of computational thinking. Okay. So there is another parts, but let me and do a few jumps here so that you don't lose your focus with me. So anyhow, algorithms, we said, is a way to describe a solution to a problem. We are able to describe a solution to a problem using three ways. Flow charts you have taken before.
Yeah.
And pseudocode and program code. Program code can be in Java or Python or any programming language. Pseudocode. Did you hear about pseudocode before?
I've heard it before, yeah, but I haven't done.
So typically what they do is they take flowchart is much easier than anything else. So they always describe a problem using a flow chart, and then there they start to move on to pseudocode. Pseudocode, it is similar to programming, but it is in a simple English language and not programming language specific. So most of the programmers who even work in your team, you will find sometimes programmers who only know Java, and another programmers who only work or like to talk about Python. And both have a different syntax. So they don't use exactly the same way of programming or the coding way. So if you want to put the Java programmers and the Python programmers on the same table to discuss how to solve or to make a project, then you need to talk about a generic thing that everybody can understand. It is just a bare English. So we talk about pseudocode. Now, I would like you have a look here and tell me what can you understand from these few lines of code.
Okay. Okay, so they're just adding 2 and 5 together.
Okay, that's excellent. So you managed to understand it in just a few less than few seconds, right?
Yeah.
Okay. Do you understand what he's trying to do here? Okay. Do you know what is the meaning integer?
Yeah, number basically.
Okay.
Integer is basically like a whole number.
But you studied? You already studied? What's the meaning integer?
Yeah.
Okay, good. And you see here that so do you see the way that he assigned two to first? He using an arrow, right?
Yeah.
He's not using equal.
Yeah.
Okay, good. And this is a typical example of a flow chart, and I think you know it. I no need to go through it unless you have a request from that. But in general, so just let me share. Okay. So I will just to give you a fast example of here. We would like to actually develop animal guessing game on as a program on a phone. So typically, most of the time, if you want to, sorry, seems that there is something. Okay, yeah. So most of the time, if we want to write something that is that can work on Android phones, for example, Java is one of the ways that we are able to use. Okay, so now this is a program that you want to develop in Java, but then we have to think. Okay, I tell you, okay, you have to show an animal picture, and the user have to guess from 4 choices which one, which name of animal match actually the one in the picture. Okay, so we will think, okay, we have inputs that we would like to deal with. We have to think, we do a process for something, and then we show an output to the user. The output most probably is either the user already selected something correct or even wrong. So you see here
Yeah.
lion, right? But then maybe the user choose bear instead of lion. So we have to accept his choice, and then we have to show him what is correct if he answered correctly or wrongly. And maybe we have to show him a score because this is kind of game that he is
Yeah.
playing. So imagine that this is a project that you have to do, and I will
Yeah.
ask you to make actually and simplify the steps that you would like to take to be able to solve the problem. What
Okay.
kind of
Okay.
steps that you would like to actually do? So we typically in this kind of situation we use something called decomposition. Let me share with you how it
Okay.
looks like
Yeah.
so it sticks to your mind. So decomposition is a process of breaking down complex tasks in a sequence of simple subtasks or problems. And how we do that, we have a standard way that's called a structure diagram. So this is a
Okay.
big task. Have you seen that before?
Yeah, yeah, I've seen this. Yeah.
Okay, so you have a task and you want to divide it into smaller subtasks. Okay, just without going into too much details, if you have the animal guessing game in this way, okay,
Yeah.
so we know that, okay, we have to deal with images because we have to make the animal picture appear to the user. And we
Yeah.
have to also deal with the user input. We have to
Yeah.
deal with the scoring. So we have to
Yeah.
always calculate a score for the user, either he fail or even succeed in his choice. And we
Yeah.
need to have a menu. Okay, so we are
Mm.
able to make the user able to exit the game or even to restart playing a game again,
Yeah.
his game and so on. So this is
Yeah.
a starting way of actually decomposing and making things much simpler and easier. But there is another way, yes. So also without going into too many details in the game itself, because that's not our target at the end. But as you see, here, we reach it a fine level by dividing the tasks. We talk about images, but then what to do? There is many things to be done with images. We have storing image and displaying image, right?
Yeah.
And then
Yeah.
if we talk about user input, we have to validate the user input and compare the input to the answer. So, and if
Yeah.
we also want to break storing the image, you will find that, oh, so we want to store it on the cloud. So we want to store it outside the phone that need internet, or we want to store it on the phone itself. And is there is a way that so are we able here to store what kind of images? Will it be compressed, or what kind of formats that it will use? So you will find that, oh, there is many more details that also we want to discuss to make things slightly simpler here and there. So now, in summary, can you tell me what did you understand so far from me about the decomposition in general?
You like separate your options into different subsections to make it easier for you to like solve the problems by
Okay.
making it simpler.
Yes, by making any problem simpler, you're able to tackle it one by one, right?
Yeah.
Okay. Excellent. Excellent understanding. Okay. Good. Okay. So now let us I share with you here. Did you play Minecraft before?
Yeah.
Okay. Excellent. So, and you have an Android phone, right?
Yeah.
Okay. So just to share with you, most of the games and the programs on the Android phones, they are all programmed in Java. Okay,
Mm.
so
Mm.
and also many apps on Android phone and tablet, they use Java, but not only that. There is another programming language that have a slight advancement on top of Java, but I would say
Mm.
maybe 70 to 80% of um, of the applications on the Android phones is made in Java. So this is
Mm.
an important programming language that actually is still being used. So
Yeah.
Java here,
Yeah.
previously when we started, maybe more than 25 or 30 years ago, we didn't
Mm.
study Java in university. Why? Because
Yeah.
mostly they focus on in C on and C++. Okay,
Mm.
Java was
Mm.
not as popular. Was just still coming to start up. Okay, so and
Mm.
Java is much easier than C++, and you will
Yeah.
notice why is that. So
Mm.
as we said, Java is a programming language, and any programming language is like a normal language that we talk. So if I
Yeah.
tell you, I speak to you in English so that we both understand each other. So
Mm.
you have to choose a programming language that the computer can understand to be able when
Yeah.
so that when you tell the computer what to do, he really understand. But please not something. Computers does not really speak Java. So we have to actually translate,
Mm.
compile, okay? The Java
Mm.
source files that we write that end in .java, normally any Java files that you write will end up in .java,
Yeah.
into
Yeah.
something called class files. Did you hear that before?
No. Not no.
Okay, good. So the class files will end up in class. Do you know
Mm.
what is .text? What is .gpg?
Yeah. Yeah. Dot .png. You have all the different, like, for images is different, for notepad, like text is, they use different file
Excellent.
like types. Yeah.
Okay, excellent. So you know that this is an extension of a file, right?
Yeah. Yeah.
So here we're also talking about extensions. So when we write any Java file, uh, any Java programming file, normally it
Mm.
ends .java. And
Mm.
then you take this .java file, which is, for example, he called it here person, and then you
Mm.
start to compile it using a compiler. So you are not able to execute any programming file without a translator. The translator in our case
Mm.
is Java compiler because we are writing Java. If we are writing Python, we will use a Python interpreter. So
Mm.
every programming language need a translator first before the computer can understand it. So now we
Mm.
do the
Mm.
compilation process, which transfer the person.java into person.class. The class file that is produced as a result of the compilation is something that the computer actually can really understand. So it
Mm.
means it can execute it. So it means that this is contains ones and zeros. Okay.
Mm. Mm.
So the source file is a file that you yourself can edit, and this is what we call the source file. So
Mm.
any project source files or any coding file that we use the word source file with it, either it's written in Java or any other programming language, it means that it is editable by human. And if it is
Mm.
editable by human, the computer cannot run it or understand it directly. It needs a translation process. So we have to
Mm.
close and we have to open again. This is another 30 minutes past, and we open
Mm.
again the same Zoom link. Okay.
Okay. Okay.